Stop guessing which motor is fastest for your robot's linear slides. Choosing wrong slows down your system and hurts your performance on the field. And you need real data to make the best decision. In this video, I'm giving you exactly that. I've tested every legal FTC GoBilda motor from 30 RPM all the way up to 1150 on a standard Misumi SAR330 slide setup that reaches meter high and under various loads. You'll see the actual cycle times possible so you can pick the right motor for your robot. I'm Coach Brad. I've spent over 10 years teaching robotics. I've coached national winning champions and Inspire Award winners, so I know what separates good design from the great ones. We'll look at the testing rig setup first, run through the data for each motor, and then finally we'll talk about some summaries to give you the information you need to build faster, more competitive robots. Let's get started. So looking at the mechanical setup here, I have 3 Misumi SAR330s connected together on a continuous rigging. On the extension and retraction string are running on the same adapter. Next is pulley. I've got a 1-to-1 gear ratio using some acetal gears so that when I go to replace the motor, I don't have to actually replace the pulley and restring my slides every single time. On the top bar here, I have a quick little bar here with a few different zap straps attached so that I can grab weights of different sizes. These are 1 kilogram weights and the small ones are 500 grams so that I can move up in 500 gram increments and load that somewhat balanced across my system as we move up and down. For the electronics, I have 2 different LEDs. One is a green LED, one is a yellow LED. The green LED looks at the extension section and the yellow LED looks at the retraction section. The green LED will turn on when retraction has started and it will turn off when retraction has met its max height. Same thing for the yellow. It will turn on when retraction has started. It will turn off when it's met its base level. To know when my extensions have reached the bottom, I'm using the encoder that's attached to the motor here, and then everything is controlled off of a button toggle switch. Lastly, to keep track of our cycle times, I've got a tracker here that tells us what our extension time was, what retraction was, and then as well as what our cycle time was. I'm just using time monotonic to do that as we're running through our motor encoders. So if I were to run this in a full cycle, I would tap the button, green LED turns on, turns off when it's up the top, brings it back down, turns on bottom. There is a 300 millisecond pause at the top, and that is accounted for in the cycle. Last things to confirm, I'm using a fully charged battery here on a RoboClaw 12-volt 30-amp microcontroller. The battery I'm using is the same one that is legal in FTC, so you can be sure that this data is always going to be the same, and it should be pretty applicable for you based off of your tests. So let's go get started. We're kicking off our motor test with the 30 RPM motor. Now, there is no way that you should ever drive a 3-stage SAR330 system using a 30 RPM motor. It is just so slow and there's so much torque that it is not at all the right motor for the applications. But we are starting with this as an experiment because it makes sense for us to be thorough. We've got access to the motor, so we might as well see what our baseline is. So let's go ahead and take a look at how long this thing goes from up and down. And now I'm going to go grab a coffee and I'll be back in about 30 minutes once this thing has finally dropped itself back down. You'll get 14.3 seconds on the way up. And 25.19 for a whole cycle. So 25 seconds. If you were in your driver period for an FTC match, where you would do 5 rotations a match, that is not very good cycle time. Let's see if it can lift up a full competition robot, the lightest competition robot I've seen, all the way up to the top. Lightest competition robot at Worlds in 2024 was 8.3 kilograms. So we're going to go ahead and load up 4 kilograms here. And let's see if we can lift this all the way up to a triple stage. There's so much lean in this Misumi slides from this angle that it would probably break the slides before the motor would give out. So your 15.3, it added about a second on the way up, so barely even working this motor. 26 as a full cycle time, you added 0.4 seconds to this, and that is not a lot of time. So let's go ahead and see if I can lift up one stage, the heaviest that I have access to today. which is 9.5 kilograms. So if you had an 18-ish kilogram robot, maybe 19, give or take, the weight of these slides, let's see if you could lift that up for a single set of the stage. So most definitely you're lifting it up. And not only that, a 3-stage Misumi SAR330 slide is also capable of not breaking under that. Now, you could probably lift this up all the way if you had 2 slides supporting this on each side. But right now there's so much tilt out this way at such a high height that I don't really want to run this thing anymore off of this cantilevered weight. So let's swap this thing out for the next motor and see what our weights are. So moving on up to the second motor in our lineup, this is the 43 RPM motor. Let's take a look and see just how slow a single cycle time is. Just to extend, you're looking at 11.16 seconds. And retraction is 8.36, so it's a full cycle time is 19.5 seconds. You'd get 6 of these in a 2-minute match. That is not a lot of cycles. So let's see if we can move up a single stage and just see how much this thing can lift. But let's take a look and see if it does 4 kilograms. So with 4 kilograms, you're still getting a full 3-stage extension. So if you really needed to lift up that high, you could definitely pick up your robot, use the 4 kilograms. Let's go up and go up to the full 9.5 kilograms here. Again, just absolutely powering through a single stage of this slide here. 43 RPM motor, 100% could lift up a competition robot. Is it practical to use with Misumi slides? Probably not. You should probably set up some sort of different setup. Let's go ahead and move on up the motors here. And continuing to move up the chain of a bit of ridiculousness here, we've got a 60 RPM motor. Let's just see what our baseline is going to be. Whew. Takes you 7.5 seconds to go up. Takes you 5.5 seconds to come down. That's a full cycle time of 13.36. That is really slow. That full cycle time, you'd get like 8 cycles in a match. I wouldn't recommend this. But let's just see if it can go ahead and lift a competition robot off the ground. So we're going to load up 4 kilograms here. And we barely slowed down. We added about half a second to our cycle time there. So now we're just going to go about halfway up and see if it's capable of lifting much more than this. So we're going to go in probably 2 kilogram jumps here just because of how heavy this thing is. 6 kilograms. And you're lifting yourself up off the ground with 0 issues at 6 kilograms. Now let's see if we can get 9.5 off the ground, no problem. And she's lifting a single stage slide at 9.5, no issues. Let's go ahead and swap this over to the next motor in the gambit and keep on going. Okay, so we have the 84 RPM motor set up here. Let's go ahead and get a baseline with no load. Looks like our baseline is about 9.83 seconds. Now, realistically, you're probably not going to be using this for any sort of speed slide here. So let's take a look at how much it can actually lift. 5 kilograms. Those Misumi slides are starting to bend out pretty good at 5 kilograms. So let's do 9.5. So could a 84 RPM motor lift up a 20-ish kilogram competitive robot? 100%. Let's swap out the motor and keep moving up scale. So the encoder's reprogrammed, we got the new motor on. We're now looking at the 117 RPM motor. So let's go ahead and get a baseline. We're looking at about 7.99 seconds as a baseline. Realistically, you're not going to be using this as any sort of speed. So let's see how much this thing can actually lift. 4.5 kilograms. Barely breaking a sweat, 4.5. So let's see if it can lift 9.5. And you're still lifting 9.5 pretty easy. Could you lift a competition robot with two 117 RPM motors? Yeah, likely you could on this setup. All right, so now we're moving up to the 223 RPM motors. Now we're starting to get more into the territory of what you might use for a sort of speed lift. So let's go ahead and get a baseline. Looks like we're getting a pretty consistent baseline of about 4.03 seconds. Let's go ahead and add 500 grams and see if it even blinks. We're setting about an average of about 4.12. Let's go ahead and swap that out for a kilogram. This is up an average of about 4.18 seconds. Let's add another 500 grams. You have about an average of about 4.3 seconds. Let's swap this out for 2 kilograms total. Hey, we're sitting at about an average of about 4.38, 4.39 seconds. Let's make it 2.5 kilos. Average speed of about 4.5 seconds on that cycle. Let's make that 3 kilograms now. Perfectly average about 4.61. 4.5 kilograms. And we're really starting to struggle about 4.5 kilograms. So you're looking at about 5.29 seconds on 4.5 kilograms. I think realistically you're lifting 4.5 kilograms, but are you really going anywhere with that? I don't know if I would consider that very successful. But let's see if it can actually physically lift anything more. It was getting a little tight near the top of that last cycle though. Let's go for the full 5 kilograms. It's lifting there, but it's getting real struggle. Let's go for 6 kilograms. I'm going to say you're probably going to chop off about 5 or 5.5 kilograms. I don't know if I would lift 6 kilograms in this bad boy. That's not looking too healthy up at the top end. All right, so let's start with the baseline of our 312 RPM motor here. Okay, it looks like our average cycle time is about 2.95, 2.96 seconds. Let's add 500 grams and see how that changes things. And that puts our average cycle time about 3.05 seconds. Let's change that up for 1 kilogram. See how that modifies it. Okay, we're looking at average cycle time of about 3.16. Let's go up to 1,500 grams. Okay, really starting to feel that now. Average cycle time of about 3.28 seconds. Let's move up to 2 kilograms. Brings our average cycle time to about 3.45 seconds. So we're really adding up. Let's go to 2.5 kilograms. Okay, and we're looking at about 3.65 seconds, 3.64 roughly at 2.5. Let's go all the way up to 3 kilograms. It's really starting to get labored. Okay, we're looking at an average of about 3.89, 3.88 seconds. Let's move up to the big boy and see if we can do 5 kilograms. Okay, let's see if we can even lift 5 kilograms. Whoa, yeah, that's getting real heavy. I'm going to say 5 kilograms is going to about max that bad boy out. And we've got about 6.23. I don't want to run that one through a second test. So we're going to say that you probably shouldn't use 5 kilograms on a single 312 motor. Okay, so I've got the 435 motor hooked up on here now. Got a reprogram for the new encoder positions, and let's get a look at the baseline. I've also taken and swapping out a brand new battery so that we're nice and charged at 13.2 volts. So let's take a look at what the baseline is. So it looks like we're sitting about 2.04 seconds as a baseline. Let's go ahead and add out half a kilogram, see what that gets us. Pretty good, added about 1/10 of a second. Looks like we're averaging about 2.12, 2.13. Let's swap that out for a kilo. And we're a mighty consistent 2.25. Let's go for a kilo and a half. Well, pretty big slowdown on that one. 2.38 is our average. Let's go up to 2 kilograms. You could really hear the motor starting to work on that one. Okay, we're sitting about 2.57 on average. Let's go up to 2.5 kilograms. You're looking at about 2.88, 2.89 for an average. We'll see if it can even lift 3 kilograms realistically. Let's give this a test. Ooh. Looks like you're probably going to max out about 3 kilograms on a 435 RPM motor. You're sitting at about 3.28. I don't know if I want to run that too many times just because of just how slow that got. So let's keep moving up. Okay, so it's time for our last test. This is the 1150 RPM motor. I've swapped out a new battery. I've got our encoder reprogrammed to our new start and stop points. So let's get a baseline started here. Oh, wicked quick at 1150. We're looking at 0.86 second cycle time. So under a second, that's pretty impressive. Let's see what we can do when we add on 500 grams. Whoa! Throws our weight to the ground. Nope, throws it to the ground again. Let's strap that on so we don't lose that. There we go. Let's try it one more time. Oh, that is quick. So we're looking at average cycle time about 1.14 seconds. Let's see how it does with a kilogram. I'm going to knock that off. Throw on a kilogram. I think it's going to struggle here with the kilo, but let's see. Whoa, quick at the bottom. Oh, yeah, that's real quick. Real quick. In fact, we actually shattered off our zip tie there so much. So we're looking at about 0.3 seconds to come down because that is looking a little bit off, but that's because it takes about a quarter-second pause at the top. And because it takes that pause at the top, this is already starting to fall down when the motor is not powered at that point. So realistically, if you're not actually providing power to this motor, it's always going to be dropping it down. So let's see if it's even capable of lifting up 1.5 kilos. For this test, I'm going to, let's see if it's even capable. I might get ready to shut this thing off when we need it. Oh, yeah. Yeah. So you're not even lifting 1.5 kilos with a 3-strung system on an 1150 RPM. So with that, all of our tests are done. Let's go ahead and take a look at the data over time for all these different motors so we can see and compare how they overlap with one another. So let's start cracking through some of the data. First up, we're going to look at is just lifting capacity. We'll talk about which robot is capable of lifting 4.5 kilograms first. Anything from the 30 through the 223 will be able to lift 4.5 kilograms all the way up. Now you got to remember, we're likely going to double this because you're probably going to have 2 of these linear slides together. So you're looking at about a 9 kilogram robot total for a full 3-length extension. So if you need to get this thing all the way up to a whole meter high, depending on how heavy it is, if you have a really heavy part on the top of that, you could do it realistically with a 223 motor. But you could realistically do it with anything from 30 RPM all the way up to 223 RPM. At 312 and 435 could likely lift up that 4.5 kilogram, but again, they're only getting it up part way. It's not actually getting it all the way at 3-stage, and that is that full 3-stage lift. The next one is whether it can lift 9.5 to at least a single stage, and everything up to about 117 could. Realistically, about the 223 probably could as well. And remember, this 9.5 kilograms is actually probably more like 20 kilograms because you're going to double them up. So that 223 could likely also lift you up a little bit. So if we look at the cycle time for the 4.5 kilograms versus the motor RPM, there's really no reason you should ever use anything under a 223 RPM motor for any speed linear slides. And even then, 5.29 seconds is really not all that slow for a full cycle at 4.5 kilograms. When you consider the amount of time that it takes for your robot to get to and from different parts of the field, if you're going to be lifting yourself up or lifting up your mechanism as you're transferring and lifting it down as you're transferring back, that 5.2 seconds really doesn't seem as slow as you'd think. Well, now let's take a look at the cycle time comparison for the kind of 4 motors you may consider to use as sort of a speed linear slide. Green is 223, yellow is 312, red is 435, and blue is 1150. So if you have a really light mechanism, it seems clear to me that you should be using the 1150 RPM for that if you have a very light claw at the top end. I mean, if we're talking, again, this is only set 1 slide, so you should really double all of these things. If we're going to look at that 1150 RPM at 500 grams, if you're talking about lifting a kilogram, that's a 1.14 cycle time for a kilo of lift. That is insanely fast. Likely your robot's not even going to have time to bring those slides up and down by the time you have to move to where it is that these things need to actually lift to. If you're talking about a little more general purpose, the 223 all the way up to the 435 were all fast enough at lifting up to about 3 kilograms. But obviously the lighter your system gets, the faster you're going to go. Now, if you're going for any sort of speed here, if you need to lift more than a kilogram or 2 kilograms, it looks like you should go up to about a 435 motor. Now, that recommendation seems a little bit off if you're going to be lifting a kilogram, that I'd suggest you go to a 435 as opposed to 1150. And the reason I say that is because you're going to be pulling a lot more current from that 1150. If you remember that 1.8, it slowed down significantly up at the top. In fact, we can look at the cycle time, it's almost double what it was for that 500 grams to 1,000 grams. So if you need to lift about 2 kilograms, you should probably move it up to about a 435 because you're just not going to be putting as much strain on that motor. Because the higher up we go in that weight, the more current you're going to be drawing, the less current you're going to be having to pull from other things. So at the end of the day, when it comes down to which motor should you choose versus the load you're using, if you are trying to do anything under a kilo, you choose the 1150. Anything between 1.5 kilos all the way up to almost 3 kilos, you should be using the 435. That seems to be getting the best data from my tests. And then if you're going to be using about 4.5 kilos, 223 is your good one. And then 6 kilos, about 223 is again kind of your choice. But if you need to lift a really heavy section with linear slides, try out the 117. Would I suggest that you actually do use the 117 as a lift mechanism with these linear slides? Probably not. But it would be a way of adding some torque to your lifting mechanism if you need that. I hope you found that data really useful in deciding what motor is correct for you to use inside of your project. This testing took a really long time for me to put together. It'd be great if you could leave this video a like or subscribe if you found this useful, and then share it out with some other teams who you think might also find this data useful. And best of luck with building your robot this season.